go live already now.
Yep, indeed.
Okay. Yeah, I pressed to go live. Let's see. It will take just a few seconds to catch up. So we should be live by now. Hello, everyone. It's Patrick and Karen here. It's today we want to greet you for the Chaos Engineering Bootcamp, which we will run today. Patrick, feel free to introduce yourself. Tell us a little bit about yourself, what you have been doing lately, and how you are related to this amazing technology called Chaos Engineering.
Absolutely. Thank you, Karen. So welcome, everybody. Welcome to today's Chaos Engineering Bootcamp. We're going to be running an introduction to the concept of chaos engineering. We're going to play around with some of our first initial experiments here. So let me first share my screen so we can get started directly after that. So yeah, so here we go. So as an introduction, my name is Patrick. I work at Nuaware as the lead architect for the EMEA region. And basically, Nuaware is a software distributor that operates in the cloud native space. So we work closely with technologies like containers and Kubernetes. We look at cloud native security, but also software supply chain security and all those kind of tools. And as a third pillar in our organization, we do a lot with site reliability engineering. So things like incident management and incident response. We also do observability and monitoring. And one of the core things, and that's what we're here for, is chaos engineering. It's one of the most important pillars of site reliability engineering as well. So today's bootcamp is going to be mostly hands-on and driven by hands-on exercises. So in case you haven't done so already, and I'm going to paste the link just to be certain once more in the chat box here. Make sure that you register for an account on the Instruct platform. So you should find the link right now in the chat. We are going to be using that platform for the exercises and the hands-on activities. Everything is going to be web-based, so there's no need to install any additional tools on your systems. And right before we're going to kick off the actual exercises, I'm going to provide you with another link to add all of the lab environments to your personal study room, so you can get going relatively quickly as well.
Yeah, Patrick, as you do it, let me add real quick here. So everyone who will stay until the end and will complete this bootcamp today will receive from Patrick a certificate of completion. That's issued to your name. That's super important.
I was about to tell that as well.
Oh, great. And another addition as well. We have 5 amazing looking like T-shirts provided by Gremlin's marketing team, and we will raffle them off at the end of this event. So make sure again and again, stay until the end, take part in the raffle, and maybe you will be one of the lucky ones.
And a really important one as well is when you sign up for the account, make sure that in your profile in Instruct, you register with your full name, because we're going to use that name on the certificate that is going to be sent out to you. So make sure you spell that correctly over there. Cool. What's today going to look like? As I mentioned, is mostly going to be hands-on. So I'm going to do an introduction into chaos engineering and the concepts of chaos engineering. It's going to take no more than half an hour, and then we're going to actually go into the lab environments, running our first experiments on our applications. So before we get going, let's dive into what chaos engineering exactly is. Where do we start? And that whole has to do with the fact that traditional testing isn't enough anymore. The emergence of chaos engineering actually makes a really lot of sense, because traditional testing doesn't solve all of the problems that we see coming on with new technologies and architectural enhancements. With modern applications, what we see is dependencies on networks we're no longer in control of, infrastructure that we don't own. We have orchestrators that are complete black boxes to us. Our applications are built on open source or legacy dependencies that might have all kinds of unknown behaviors. And last but not least, people can be a really unreliable factor as well. So when testing the code of an application is never going to uncover all of the errors we can run into. And as an example for that, if you look at back in 2017, you might remember that Amazon had an outage in their S3 East region that took out a large portion of their end customers' applications. That was caused by a single human error. So organizations really need new ways to test all of the other parts of the application stack, just to be sure that everything is configured accurately and that all of the processes for incident response and incident management are in place correctly. So outages typically always occur at the most inconvenient times possible. Most of us have been paced out of bed at 4 a.m. in the morning, trying to troubleshoot an issue while we were still half asleep. Chaos engineering actually focuses on finding issues in your environments before they become outages. Because let's be quite honest, troubleshooting an issue is going to be a lot more fun during the daytime with enough caffeine in your body and your entire team and completely engaged on troubleshooting the issue, right? So what is chaos engineering exactly? Well, from that perspective, I'd like to take it from a bit of a different look, and I look up the word chaos in a dictionary. And you're going to find at least two different meanings of the word chaos. First meaning, and that's the most known one, of the word chaos is complete disorder and confusion. And although I do recognize that from my home because I've got 2 small kids, this is not something we typically recommend to an enterprise organization. However, if you look up the meaning that is used in the physics community, it's going to mean a slightly different one. And I'm going to quote here, the property of a complex system whose behavior is so unpredictable as to appear random owing to great sensitivity to small changes in conditions. And that is exactly what we try to uncover when we're practicing chaos engineering. We're trying to find the changes in conditions for our applications that have a huge impact on the predictability and the reliability of those applications. And we do that by carefully experimenting on our systems to reveal weaknesses, learn from them, fix them, and keep verifying them in an ongoing fashion. So breaking systems on purpose is what we're basically going to do. And for a lot of organizations, that sounds pretty scary at first. But I want you to imagine living at the end of the 1700s and a guy called Edward Jenner comes up to you suggesting to inject a small doses of the cowpox virus into your body. That is meant to trigger your immune system, identify the threat, and start producing antibodies to fight the virus before it makes you sick. And nowadays, being vaccinated, especially given the COVID situation we're in, is a no-brainer to most of us. And chaos engineering basically does exactly the same to your systems. We're going to introduce small but controlled issues in your environment to start identifying the weaknesses in your applications and ultimately making those systems a lot stronger than they were. And as I mentioned, a really important part of resilience is people as well. And another part of chaos engineering is based on organizing fire drills. Yeah, the time it takes to detect and resolve an outage, typically you measured by things like your MTTD and your MTTR, or your mean time to detect and mean time to recover, is not only determined by your system's reliability, but also by your people's ability to respond to incidents as they happen. Chaos engineering also helps you determine your resilience in this space by organizing so-called fire drills. And those are pretty similar to the fire drills you may already be used to in your own organizations. Yeah, sitting down in your office, the fire drill goes off, and we're going to simulate an actual fire. People leave the building, see if the people know the right way and the right procedures to safely leave the building and come together in a safe, secured location. Fire drills and chaos engineering basically do exactly the same thing. You sit down, you take a cup of coffee, You run a fully controlled experiment, and you see if your teams respond in the way you expect them to respond. Do they know where to find all of the playbooks that they need to look into? Does the incident response system work as it's supposed to? Is your application capable of remediating the issue itself? All those kind of things is what you're going to look at when you're organizing a fight drill in your organization. And typically we do that because of the cost of downtime and the cost that downtime brings with it. And typically that cost is seen as loss in revenue and employee productivity during an outage. However, there's a lot of costs that occur after the outage as well, some of which we as engineers might not even be aware of. Yeah, does your employer have SLA agreements in place with your customers? That might mean that they will have to provide them with chargeback for that outage. And what about the unmeasurable ones like brand defamation? Yeah, you're losing customers because your services are interrupted so often. Or employee attrition, because they get burned out by being paced during the week, during the night, week after week. At some point in time, they're going to start looking out for other jobs which are going to provide them with less stress. On average, 1 hour of downtime will result in roughly $300,000 in losses. And those numbers will even get bigger with companies that operate at internet scale. So, for example, if you, it's estimated that Amazon loses a whooping $13 million per hour of downtime. So those numbers are just staggering. So the basic principles of chaos engineering is planning the experiment, containing the blast radius and magnitude, and scale or squash the experiment. And first, you start, as I mentioned, by carefully planning your experiment. And I'll get back to that in a bit. But once you've planned that experiment, you're going to start really small, and you're going to run that in an environment where you know the impact is going to be low and where you're comfortable with experimenting in. Don't start hitting your production services right away unless you're absolutely sure your job doesn't depend on it. This is basically what we call the blast radius. The magnitude is the impact that an experiment has. So for example, if you're going to cause some CPU load on 3 of the 5 microservices in your application, those 3 will define your blast radius. The percentage of load that you put on those CPUs is going to define the magnitude. So you see there's more than one way of scaling those experiments. And once this experiment was run successfully, you're going to rinse, repeat, and start increasing the scale. But how about planning that experiment? Well, as I mentioned, instead of just going out and crashing EC2 instances at random, like Netflix's Chaos Monkey is doing, we suggest our customers to use a more scientific approach towards chaos engineering. First thing you do is you form a hypothesis. What do I expect my systems to do when under stress? How can I safely mimic such stress in an experiment? And what am I going to target first? And keep in mind that blast radius and magnitude that I just mentioned. And in the end, it is all about running that experiment and either proving or disproving your hypothesis. And once that's done, you're going to expand the scope and you're going to retest. And you're going to retest again. And how often are you going to test? Well, in the ideal world, you're going to be continuously testing it. Yeah. At some point in time, validating your fixes from previous experiments is going to be part of your CI/CD pipelines, meaning that whenever we fix something that after an outage, we automate the entire testing procedure around there. And once we publish a new version of that application and we want to release that towards production, it first needs to pass a set of chaos engineering experiments to make sure we don't drift back into the same failure mode we just had. Another really important part of chaos engineering experiments are your abort conditions. Those should be part of your planning as well. And abort conditions basically are defined when we halt an experiment. Yeah, when is the impact deemed completely unacceptable? Is that whenever a certain amount of latency is introduced, or whenever the user experience is severely degraded? And always make sure that you have an easy to reach big red button that immediately stops all of the attacks that are going on. So game days is a concept you're going to be running into whenever you look at chaos engineering. But what is a game day? Well, game days basically is a time to get together with the entire team. Yeah, do you know how your applications behave when your infrastructure goes sour? Is your application architected for failure? But what if the problem occurs that isn't covered by your architecture or things that you haven't thought of before? Does your application still fail in a graceful manner, successfully remediating the issue itself? Well, game days basically are an excellent method of finding weaknesses in your systems in a controlled and almost scientific way. And if you see in the quote here, the best time to learn about fires when they are actually on fire. Yeah, trying to perform stress on your applications to see how they behave is going to tell you a lot more of those applications than you were used to and you had architected them before. So game days combine both system failures and incident response in one single event. And during a game day, you're going to have all of the stakeholders teamed up, and you're going to be jointly thinking about hypotheses about what could happen to your systems. And then together, you're going to start building an experiment to either prove or disprove that hypothesis. And of course, you're going to run this experiment during the game day. Why during? Because your entire team is engaged. They're full of caffeine, well prepared to respond to anything that might go wrong and ready to go. And basically, that's the opposite of what your people will feel like if you page them in the middle of the night with a production down situation, of course. So there's a couple of benefits that go into game day. First of all, validating that your incident response processes are in order. Yeah, you want to make sure that in order to bring down your MTTD, your mean time to detect, is that you're capable of identifying a failure in your applications before your customers do. You don't want your customers calling you that you have an outage. No, you want to be well aware that you have an outage before your customers start calling you. Ideally, you're going to be failing in such a graceful way that your customers don't even know that you're having an outage. So that's where game days really help you in validating those processes and monitoring your application resilience. It's also about uncovering latent problems in your systems. Yeah, are we going to introduce software latency or a network latency in an application that consists of many different microservices that might end up cascading over and over and over, resulting in much larger latency issues in the end application. Game days help you find those kind of latency issues before you run across them in a production environment. And of course, it's about unifying your teams and educating your on-call personnel. The person or the team that is responsible for responding to an incident is not necessarily the team that is responsible for maintaining and building the application. So cross-functional collaboration between those teams is also one fairly big benefit of running those game days. And ultimately, you're going to be more confident that you're actually capable of building up the resilience as you see. So as you can see, the benefits of a game day cover both process, system, and people in the end. So we're not going to be running a full game day during this bootcamp, but if you're considering organizing one afterwards, I suggest you have a look at the documentations that our friends at Gremlin have created. It's basically a complete workbook on how you would run a game day in your own organization, how to build up those hypotheses, how to design the experiments you're going to be running during the game days, but also very important, how going to provide the feedback to the other stakeholders on what you've achieved during the game day. Remember, the cost of downtime is not always on anybody's mind, and it gets on somebody's mind when we actually have an outage. Providing feedback in chaos engineering is crucial to show other people in your organization what you've actually saved the company for. Yeah, the amount of downtime, the cost in revenue, loss in revenue that you've saved the company from when executing chaos engineering experiments. So as I mentioned, we're going to be running a lot of hands-on exercises today. So for this environment, we are going to use the Instruct platform, as I mentioned before. So what I'm going to do right now is I'm going to paste the link to the Instruct platform invite. So this invite, if you registered for an account on Instruct, this invite is going to take you to the specific lab environments we're going to be using today. Once you click on that link, you can add it to your personal study room. And once you add it to your personal study room, you should be able to open up a page which looks like this. So the Chaos Engineering Bootcamp #1, and you have the ability to start the track. Feel free to do so once you've done that. It's going to take up 5 to 6 minutes to configure all of the environments. Please wait before you start the first challenge before the actual lecture is over. But at least make sure you've registered for an account on Instruct and that you add these lab exercises to your personal study room. So once the provisioning of your environment is done, each of you are going to have their own Kubernetes cluster with the Gremlin agent and Instana deployed, as well as a demo application that we're going to try and break. So Gremlin is going to be the platform we're going to be using to execute our chaos engineering experiments. And Instana is going to be our observability and monitoring tool for today's session.
Patrick, let me just quickly jump in. People write that the link they follow gives them access denied. Can you please check what's going on there?
Yeah, just a second.
Everyone, stay calm. It's okay. Patrick is checking right now. So,
no, it works for me. So make sure you have registered for an account and make sure that you've logged in, because otherwise you're probably going to get that as well. If I open up the link right now from the that I just pasted in the Slack, it will bring me to the correct page. So please make sure you're logged in into Instruct before clicking on that link. Once that setup has been provisioned, one thing to make sure we're all aware of, we're going to have our own piece of infrastructure to break, so you can break your own Kubernetes cluster. However, we are going to share the same consoles for Instana and Gremlin. So before you go to execute any experiment, it's really important that you select the right cluster in those consoles. We don't want you to upset other attendees in the environment, at least I don't. So make sure you look at those carefully. So what is the specific identifier cluster? Make sure you follow those identifiers in the Gremlin console.
Patrick, just a second. Let me please jump in again here. I tried myself the link. Everyone writes that the access is denied. I tried myself. It also, I'm logged in right now, but it still stands access denied. And the message is access to Nuaware content is granted to specific email addresses. To gain access to this content, contact Nuaware. And then there are options, 2 buttons below, create account and login, but I'm actually logged in right now. So I can see my profile in the top right corner.
This is weird. Just let me check.
Yeah, sure.
Just one more. I think I got it. I think there's a typo. Can you try the one I just pasted?
Yes, let's see. Oh yeah, now I can see the link. Let's see if it works. No, it still stays access denied, and the invite link I have, the code is starting with V and ending with 9. It's the same as before.
Yeah, it is the same as before. This is. So it ends with 9, right?
It's at the end.
This
yeah.
I see what's going on. This is really weird. I found it. I found the issue. I'm copy pasting it directly from the Instruct admin console, and for some reason it keeps populating a different one.
Oh. Okay.
So just give me a second. I'm going to get you
no
the
worries,
right
no
one.
worries. It was an awareness check anyways, very good one, so that we know that everyone is involved, everyone is watching. That's great. We have a feedback loop going on. That's great. It was the first challenge,
okay.
So you have passed the first challenge, everyone.
Next one. This should be the one.
Let's try this one. Okay, so everybody please follow the recent URL posted by Patrick. Let's see, gain access. Now there is an option to gain access. You can add to your study room. That's great. I think we are good to go.
Perfect. Let's say copy-paste X issue with the Instruct platform. Okay, cool. Moving back to where we are. So once that environment is done, you're going to get your own clusters to break. As I mentioned, we are using the Gremlin platform, so I want to do a quick introduction on how that product was going to work. What you see here is the overall architecture. So basically the 30,000 feet overview of what the application looks like. So Gremlin is a SaaS hosted platform. So the entire control plane is going to be run as a hosted solution, which is available through the internet. And the actual agents that are going to be used to perform your chaos engineering attacks are what you're going to see on the left side. Those will be deployed on your virtual machines, on your Kubernetes clusters, or in containerized deployments whatsoever. So those agents are available for either Linux or Windows systems in the applicable packaging formats, or you can deploy them as containers in either directly on Docker or as Kubernetes daemon sets. And once you run them as containerized environments, and especially in a daemon set on Kubernetes, they can apply any type of experience, both on host level and on container level in those environments. So you get to attack all kinds of objects, either on host level or in your Kubernetes clusters. The way that these communicate with the control plane is based on HTTPS. So there's only outbound traffic going into the control plane, and the agents will pull the API to see if there's anything scheduled that they need to execute on those systems. All of the attacks are hard-coded in the software itself, so there's no way to manipulate those agents running in those environments from the outside world. And of course, for end users, the Gremlin platform is exposed to either web user interface or through an API, so you can extend Gremlin into your CI/CD pipelines or other integration tools that you might have you want to work with. So the demo application we're going to be working with today is going to be a fictional web commerce shop. It is a microservices application, and it is built using multiple different technologies like Node.js, Java, Python, etc. There are bugs in this application, and they are there for a reason. We don't want to fix those bugs because the idea behind it is that you're going to be running into specific behavior when trying to break the application. And this bootcamp is not about fixing the application itself, but identifying weaknesses in those applications. So where do we notice that running a specific experiment causes our application to completely stop functioning whatsoever? So that's being said, it's time to move towards the hands-on exercises. So once you've started to track, and it takes about 5 to 6 minutes, you're going to be able to start this track. One thing I want to make you aware of is whenever this screen pops up, you have the ability to go through the notes. On the third page in this notes, you're going to find the credentials we're going to be using for today. So we're going to log into the Gremlin SaaS-based platform and the Instana platform using these passwords and this username for both of them. If you've already started to track and you want to find those locations again, go to the upper right corner, click on the Notes tab, and you'll get to this page as well. So once everything is up and running, you'll have your own Kubernetes cluster. Let's see if everything's up and running for me. So there's my cluster. It's registered in the Gremlin control plane. You'll find the links on top here. And you should be good to go. Log in and then follow through all of the exercises in the hands-on activities. So there's going to be roughly 5 challenges for you guys to follow. We'll take about, let's say, 1 hour and 20 minutes, and we'll reconvene around 5:45, 10 minutes to 6 for some closing remarks after you run through the hands-on exercises. If you run into any issues, let us know through the chat, and we'll try to fix them while we go at it. If there's no other questions right now, I would say enjoy the hands-on exercises in a bit.
Let's see what's going on in the chat. I think everyone was able to get access. This is super important. Again, I will share the link in between because we have people, some people are joining later, a little bit later, like a few minutes later. So they will be able to catch up. That's important before you join and follow this link from provided by Patrick. That's important that you create an account before at the Instruct platform, and then use the link to get your class, access to your class. Yeah, that's great. We have right now about 120 people watching the stream. Probably not all of them doing the lab. You should actually. And we have about 100 people, right, on the platform. I hope it's not capped to 100 people. I hope that we can accept more.
And 101 last time I refreshed. So yeah. It looks like everybody's capable of getting onto the platform.
That's great. Is it, Patrick, is it your all-time record, or did you have another ones like with this number?
Not this much in parallel. So I think the guys at Instruct are going to be very happy because running 100 GKE clusters in parallel is probably going to give them a good weekend.
Yeah, that's a usual thing for a community. Like whenever we have an amazing stuff like event day.
So, and pretty important as well, I mentioned that during the slides already, we're going to be sharing the Gremlin control plane. So once you're in Gremlin and you navigate to the clients page, you'll see that there are a bunch of clients already. In this case, the cluster I just started, the other ones for you are probably still started. You'll see that my cluster is called Mary Beam. Make sure you identify your correct cluster. The way you can do that is in the first instruction, you're asked to look at all of the namespaces in there, and the namespace for your specific application is named with the same cluster name. So you'll see that Mary Beam here as well. So if you're going to run an attack, make sure you select the right cluster in the Gremlin platform. Another quick remark over here. In Instana, it takes roughly 10 minutes for all of the metrics to populate. So it takes up to 10 minutes before you actually see your Kubernetes cluster show up in Instana and see the actual applications. So wait for that. You'll see that these pages are still empty, but because my cluster is also just a few minutes up and running, over time you'll see that it's going to populate these pages as well. So to give that some time, but that isn't going to stop you from at least exploring the Gremlin console in the first challenges. And in the meantime, just let this populate itself.
Patrick, one member is asking, for how many hours will we have this lab?
So the lab exercises are going to time out after, I think, roughly 2 or 3 hours. So when you've run it, after that, you'll have access for the to the environment for another 3 days, and you can run it up to 2 times again. So if you want to revisit the tracks in the coming 3 days, you can run it twice after this as well.
Okay, great. Another member is asking where to find the token in step 2.
The token in step 2. In challenge 2, does he mean challenge 2 or?
Probably. I'm not sure 100% about it.
I'm not sure which token he's talking about, to be quite honest.
So if everyone in the chat experienced the same thing and knows the answer, please write it into the chat. A lot of people are reporting that it's still creating the environment. What is should be probably okay.
Yeah, it takes 5 to 6 minutes for that entire environment to pop up. So give it some time. Now, in the meantime, let me see. Yeah, the first ones are coming up right now. You see?
Yeah.
So it looks good. Give it some time. 5 to 6 minutes is what it typically takes to provision the infrastructure.
Okay. There are some reports that if the environment failed on some members to start, and they have to start try again. So if it's the case, then try again, please.
Yeah, make sure you refresh the page as well.
Yeah, that's important.
It might be a JavaScript error in your browser as well.
Okay, so make sure to refresh your browser page. Maybe it will help. There are actually some reports that it helps after the refresh. That's also definitely a very interesting experience because there is no simulation. This is just a real environment which is being created right now. So you have everyone has a first-hand experience of doing it, and that's not a fake. That's a real thing. And sometimes it just doesn't create what you want, and you have to try again. There is a question, is it better to use a private window? But you know what? I guess it will be difficult because then you have to log in again into the whole environment, right?
Yeah, indeed. And should it make a difference?
Yeah, probably will not make much of a difference. Yeah. How many clusters do we have, Patrick?
I see 5 now in in Gremlin, and I see a lot of them still being created in the logs.
So most of the people, I guess, are still waiting for
Yes.
for the cluster to be created for them.
I think we're giving the instruct service a bit of a hard time with all of the Terraform scripts that we kick off right now. But it is still working, so it might be a bit slower than we're used to, but it is still working. Everything is being created, and we see clusters popping up.
Yeah, so Instruct platform is actually originated in is originally from is a Dutch one, right? It's a
yeah,
Dutch
so it's sped out of the Xivia group. So
okay.
the guys that you probably know from tools like Excel Deploy, they actually they sped out of that.
So these guys are not sleeping yet. So if there is any like urgent case, they have to take care of it right now.
Yeah, they will know. They will know about it.
On your side, Patrick, are there any like error logs that would say like what would be the reason why the cluster is not being created, or anything
it is being created. I'm seeing in the logs that it actually runs.
Okay.
It's just what it does. It underneath the hood, it creates a separate GCP project for every attendee.
Okay.
And it's just a bit slower than normal. And that's probably because we're running them in parallel.
And I really hope that you have a flat rate with Instruct and not have to pay like for every spinned up instance there later on. We notice asking if we have the manifest files and other Gremlin scripts, can we run the similar lab on our Kubernetes cluster?
You could, but then I would have to share all of the credentials and certificates, and that's not something I'm really willing to do.
No, yeah, theoretically you can, but you know, in this case, yeah, it would be like a complicated thing from our side as well to share all the instructions and so on and so forth. That was the idea behind the bootcamp like this, so that their environment will be provided. It will eventually be provided, but you know, the clusters are being created as we speak now. Patrick is watching it, and but the throughput is not as high probably as we demand right now. Yeah.
I'll send the guys that instruct a Slack message asking if they see the load causing an issue.
Mm-hmm. Gurav is writing that he was able to create the cluster, so congratulations. Hopefully we'll see more reports like this. There is a nice suggestion of CyberPow, the user with the name CyberPow, to run a raffle in between. Yeah, that's a great idea, but let's really wait until the end, because you will experience hopefully how the whole thing will be created, and you will be able to share your experience in the feedback form. There will be a feedback form provided to you. You can fill it out with your feedback, and then we will take the names out of this form and raffle among the people. The 5 amazing looking, I must say, t-shirts. If you haven't seen the Gremlin t-shirt, it's just great. Gremlin is a platform which you will be using today. It's a chaos engineering platform, and the t-shirts are amazing. They have a big face of Gremlin on in the front of the t-shirt. And this class, which people were able to unlock with the invite link, they will have it like for a few days, I guess, right?
Yeah,
Pat?
correct. Yes, correct.
That's great. So if they will struggle now and will not be able to spin up the environment and complete the bootcamp right now, can they like try next day the same?
Yeah, absolutely, absolutely.
That's a great relief, actually. So try now, don't give up. You're a DevOps person, probably, so you shouldn't give up in any case. But if it will absolutely not work for you, or you have like I don't know, like kids screaming around you and you have to run, that's okay. The most important thing here was to grab this invite link, which Patrick shared. I will make sure to share it again and again, so that the people who will be catching up with us will be able to grab it as well. So once you have the environment, it will be there for a few days. And once you complete all the steps, there will be like it's 1, 2, 3 steps like this. You have to complete all of them, and you will be granted the certificate, which will be mailed to your email address, which you used to register at Instruct. And again, make sure that that's your real name, not some like ABC or whatever, because then the certificate will be provided to ABC, and you probably will not make use of it. Okay, we have a few reports here that it failed on some people for the second time, and they went for the third time. Don't give up again. Try it again. We actually see some new clusters being created, right, Patrick?
Yeah, let me double check. I'm not seeing any more pop up anymore. I think we are actually overloading the Instruct platform as we speak. I've already sent a message to the guys, hoping they get back quickly.
That's a great lesson. Probably before we run anything, we have to warm them in advance. You know, that the cloud study network is going to have a bootcamp or
Indeed.
a class like this. So the user with the nickname, very short one, L, is asking if anyone was able to create the cluster. Yeah, so we have like 8 people who are probably the fastest one to click the button to spin it up and who were served first. This is just my guess. I have no idea. But we have some people who were able to get their cluster created. Yeah, so Patrick, I don't know. Probably, I don't know. Let's wait a little bit more. But I get a message here that if we can go in a kind of screen sharing mode and show that like the basic steps what have to be done so that people will have it as an information for them to proceed further later on when they have full access to the system.
That may be indeed a wise thing to do, because I'm not getting any response from the guys at Instruct, and all of the log files is still saying they're still creating all of the projects. So I normally hope to get a failure out message that we can actually do something with. So what I'll do here is I will walk you guys through the steps you would normally be doing during the bootcamp, and then you can follow along those for the guys that already have that up and running, or you can go in and try this at a later stage when the platform has come to a better state than it is right now. So as I mentioned, in this case, what we've done here is we've deployed the Gremlin agent onto my cluster. So let's have a look in what it actually has deployed. So it's deployed the Gremlin agent as a daemon set across all of the nodes in my cluster. I have a 3-node cluster. You'll see that there's 3 agents that are actually running. So everything seems to be up and running. Let's have a look if it already started to populate the information in my in Instana for me already. This is starting to look good. Yeah, so that is reporting nicely into Instana. I can see latency. I can see those kind of things. Next thing we want to double check is actually can we follow up the can we see what the application is up to? Let's get the service that is being used to expose the application on. So if I now open up a URL to this one, we see the application itself. So I can log in, I can create myself a account. Let's use my email address here. Create an account, sign up, and everything seems to be fine. And I can go through my application. I can add stuff to my cart. It is really important before you actually start chaos engineering experiment to see what your application is doing. Make sure that your application is in a steady state, so you're able to identify any issues that may arise. So we've seen the application, we've seen the clients pop up in our environment. So that's a good sign. Let's see what happens if we're going to start the first exercises. And the first one is going to be about running state attacks. State attacks are, as the notes already say, there's 3 different types of state attacks you can run. You can have a process killer, which is just going to reach out to those systems and run a specific process or kill a specific process. You can carefully select the process. You can set a filter on which kind of processes you want to kill based on a regular expression. Or you can actually start to shut down either hosts or containers. And the final one is time travel. Time travel can be fairly useful for things like trying to identify how your application is going to behave when NTP is misconfigured, or what happens if my certificates are expired or about to expire. This is where these can be very, very helpful. So in this case, we are going to run an attack against my application, and we're going to see what happens when we're going to shut down one of the pods in my my demo application. So let's see, we'll do a shutdown attack against all containers in the web deployment. Cool. So I go into my Gremlin UI, I select the cluster I want to run the attack against. In this case, Mary Beam is my cluster. This is going to bring us directly to the attacks page. And here we'll have a couple of options to start attacking those. We can attack services. Those are services that the agent has tried to identify itself. We can attack directly against the infrastructure, or we can attack against applications. The applications is not something we'll be using here today, but that is attacking an application where the Gremlin agent is actually incorporated into the application source code. So that's available for Java applications right now. And it's basically an external library that you make part of your Java build. And then once the application starts, it registers itself to the control plane, and then you can start attacking the application from there, inserting things like latency or throwing Java exception errors. And that is extremely helpful for environments where you don't have access to the underlying infrastructure, like serverless functions, AWS Lambdas, things like that. In our case, we're going to be running this against our Kubernetes infrastructure. So I'll select Kubernetes, make sure I select the correct cluster. I'm going to choose a namespace to drill that down. And in this case, I'm going to run that against the web deployment. On the right side, you'll immediately see it populates the blast radius we're going to be running in. So inside this namespace, we have 12 potential targets that can be target of an attack. And in this case, this is the only one we've selected in our replica. Choosing a Gremlin, in this case, we're going to get a state attack, and we're going to shut down one of the pods. We're going to tell a reboot, and we're going to tell any container in that pod. And let's see what happens. So it's going to schedule this attack. First of all, it said it's pending, and pending is basically trying to figure out which agent to set up with the with this attack, and then it set it in a queue. And then those agents are going to look at that queue every couple of seconds to see if there's anything it needs to execute. And once they've seen that and picked it up, it's going to start running that Gremlin on the local system, and you'll see that it goes into a running stage. This is going to wait a minute before it's actually going to restart. But looking at the pods in my environment, let's see if it actually going to restart the pods. Get in this. Oh. So we see that the web deployment is still there. It hasn't been restarted yet, and it should be triggering a restart right now. Let's see if we can. Yeah. So in this time, we see that actually it killed the pod, and Kubernetes, of course, immediately jumped in and started to restart the pod. So fairly simple first attack to run. What happens if our systems go down? This is basically fairly simple as to what, for example, Netflix's Chaos Monkey does. Yeah, shutting down a host system, see how our application behaves. Does our orchestrator pick up on it? Restart components and services in the way we would expect it to be. Fairly simple attack to actually start with. So for the next one, we're actually going to go into a bit more the other one. So let's see. First, the quiz. I need to fill in my quiz. See if I know the answers up front. 3 valid test cases for a time travel attack. Well, I explained most of them already. Validating how your application responds if SSL certificate is about to expire. Testing how ClockSeal affects integration with third-party applications. And verifying if your NTP configuration of your systems is correct. Predicting tomorrow's weather is definitely not one of the things that the attack can help you with. So in the next, we're going to look at resource attacks. And resource are basically consuming system resources. So we can start consuming CPU. We can set up disk space to fill up, or we can start consuming disk I/O. So we'll see what happens if the amount of disk I/O going for our applications is being reduced by something that's consuming the disk in another way, or seeing what happens if we're going to start memory consumption. So in this case, what we're going to run here is we're going to run a CPU attack. So let's run that against the hosts. We're going to run directly at to the host. Let's see, 120 seconds at 100% of the CPU capacity across all cores in our system. So we'll go back to the attacks page, or we go to the clients page. I'm going to select my cluster here, Meridian. I'm going to select hosts. I'm going to select one of the hosts in my environment. So let's see, sorry. Marybeam, host name Marybeam. Okay, this is the one I'm going to select. I'm going to run a resource attack. I'm going to tell the resource attack to claim all CPU in the system, run it for 120 seconds so that at least our monitoring tool is capable of picking up on that. We're going to load the CPU to its maximum capacity, hopefully, across all cores in the system. And we're going to run the attack right now. So again, this is going to set up the attack is going to schedule that in the queue. It set it into a pending state for the agent to pick it up. Once the agent picks it up, it's going to be transitioning into a running state. And it should be running right now. So let's see if we can see that behavior already back into our monitoring solution. So I'm going to go into the infrastructure part. Let's see if the CPU resources start going up. Nothing very specific yet. And now we see that indeed the CPU requests are really going up dramatically, and that's basically the agent now consuming all of that CPU capacity. It's doing it on a host level right now. If I would select the CPU attack to be run in a Kubernetes object, that attack is going to be actually deployed inside the namespace of my my Kubernetes application. So it's going to be run inside the same namespace, affecting that. One of the use cases that is fairly useful for, and we could do that later on as well, is when you're going to try that out to validate if the auto-scaling capability of your cluster is configured correctly. That's something that a lot of people actually try to set up, horizontal pod autoscaling on Kubernetes. But because of those translations on how many CPU has been reserved for that application, often people get that wrong. And it turns out at a later stage that whenever there is that actual load on the system, the autoscaler doesn't pick up on it in a correct fashion. So going through the next step we're going to go through is network attacks. So there's three main categories of attacks we mentioned. I got to go through my quiz again. Would it possibly use Gremlin inject CPU? Yes, I've just explained that to you guys. And the next one is going to be around network attacks. So what happens is we've got 4 different types. So we've got black hole attacks, which basically helps you to drop all traffic that adheres to a specific filter you put in place. We also have the ability to inject latency. So basically picking up packages before they leave the system or before they go into your application and slow them down enormously. The other one is packet loss, basically selecting a specific percentage of packages to actually drop, see how your application handles, for example, corrupted packages or corrupted streams. And the final one is blocking access to DNS servers. This is one of those typical issues that happens, especially when we have large-scale environments that are across multiple locations throughout the country that have a problem accessing DNS services and complete sites go down. In this case, we're going to be running a specific network attack. And what we're going to do first is we're going to run a latency attack. So we're going to introduce latency for 2 minutes against the rating deployment in our demo application. Yeah. So let's do that at 1 second latency. I'm going to select, I'm going to go back to my clients, select the correct cluster again. In the meantime, I see that a lot of clusters are actually coming up. Oh no, so these are actually the hosts, not even the clusters. Too bad, my mistake. So I'm going to select the rating service, and I'm going to install a network latency in that specific service. I'm going to run an attack for roughly 120 minutes. I'm going to introduce a second of latency, and we're going to unleash the Gremlin. Before I unleash the Gremlin, there's a couple of things I want you to show. We're going to be using that in the next step as well. You have the ability to create additional filters, so you can start filtering network streams based on IP addresses. You can filter based on devices, or even based on host names. Where that's useful for is going to be shown in the next exercise. The final thing I want to show you is, okay, what if we're running additional provider services? What if my application uses a DynamoDB in the backend? In this case, what has happened is that the agents have tried to figure out what kind of cloud providers they're running on, and they'll reach out to the cloud provider internal APIs to scrape as much information off of that host as possible. So in this case, it has probably found out that it's running on a Google Cloud Platform, and it's going to allow me to target specific tags with components in my environment with specific tags applied. For that specific cloud provider, and this is specifically useful for AWS, it's not configured for GCP right now. If that DynamoDB, for example, is in my backend application, I can just select the Dynamo region and say, you know what, I want to introduce that to this specific DynamoDB region, simulating an external failure, in our case, the DynamoDB database that's being managed by Amazon slowing down. I'm going to, not going to fill in any filters here, I'm just going to unleash that Gremlin. And that should be starting to introduce the latency in that application. Let's see what our application, how our application handles that. Just a second. I'm getting a response from the insert guys, so I'm quickly answering a question of there from them. Mm-hmm. So I'm seeing that the agent in the meantime has picked up on the attack, so it should be inserting that latency right now. So let's see what happens if we can actually try and do something with the rating service. We can roll into an item, and nothing really happens whenever I try to really do a rating. Go back into the application itself. Oh, just a second. And now we see that we've broken the application itself. Cool. It's going to take a while for it to get back. Okay. So as I said, there's a couple of bugs in that application that are specifically there, and we're not going to fix them just to see what the behavior is. I'm not able to use the rating service, so because of the latency we injected, the rating service stops functioning at all. So what would be the result of this specific chaos engineering experiment? Well, based on my hypothesis that what I've created is I would either get an error message that I'm not able to rate this product, but in the ideal world, if we identify that there is a problem with the rating service, my application should probably revert back and render out the rating service in total. Because if we're not able to create a rating, our end user is not even going to see that there's an issue with the application. So there's multiple ways I could remediate this issue without my end users being impacted. So let's see if we can see that in our monitoring as well, because that's one of the most important parts when you're going to run chaos engineering experiments, is do we pick up on this specific issue? So what I'm going to look at, and I'm going to see what the my application looks like. Do we see a latency issue arise? And indeed, I see a spike here. Let's see what we can see what is going on. And we see that the spike has already resolved itself, and that's because the attack, of course, has already stopped. So in this case, we see that there's a second of latency that is being identified from the rating service to the SQL backend that was going on. And that is probably causing the timeout so that we don't even get a rating in the database at all. So that's from a latency perspective. The other one I want to quickly show you is what happens when we're going to use black hole. And I want to use the filtering mechanism in there as well. So first of all, I'm going to buy something in my store. So I'm going to add this to the cart. Let's see if this works. Yep. And I'm going to have to select a country. So I live in the Netherlands, near Amsterdam. Calculate the shipping costs, confirm that. Okay, pay now, and my order was placed. So this looks fine. This is the normal behavior of the application. What I'm going to do now is I'm going to use a network attack to simulate a failure of my external payment provider. So what happens if somebody else that I'm consuming a service from is having a failure? In this case, what happens if PayPal is down? I'm trying to pay my my products with PayPal. What if they are down? How does my application handle that? I can guarantee you one thing: you can phone PayPal, you can ask them to take their systems down for a couple of minutes so you can test your application. I guarantee you their answer is going to be no. So we need a way to actually be able to simulate that failure. Again, Gremlin has excellent tools to do so. So we're going to go back into the application. This time I'm going to select the payment service. And I'm going to run a network attack. I'm going to choose a black hole. I'm going to block all traffic that goes to a specific, that adheres to a specific filter. But this time, I'm going to block all traffic that goes into the PayPal API. So I've identified PayPal.com. How is it? Is it, by the way, is it 1L or I always mess up. You know what? I'm going to do both just to be sure. I think it's 1L, by the way. And this is basically filtering only that traffic that goes out to those domains and black holing that specific traffic. All other traffic towards all of the other components in my application will still be able to communicate with one another. Just trying to see what my application will do whenever the external service provider is having an issue. Again, run the attack. Wait for the agent to pick up on the attack.
Patrick, we have a question meanwhile from users. These quizzes which are provided there, if someone makes like the first attempt wrong, can they redo it, like reassign it?
Absolutely.
Okay. Usually for
No, don't worry about those. Okay. So it's now running the attack. So let's see if I can still shop in my my web shop. I'm adding this to the cart, so it's now running that black hole attack. So I should be able to still choose this. I'm going to Czech Republic today. No, because I don't know a city in the Czech Republic. I'm going to set it to Helsinki.
Okay, another one.
Helsinki is what I do know. Confirm, pay now. And the order was placed probably because it already finished the attack. Indeed, I was too quick. So, well, you know what? We're going to run it again, just to be rerun the attack. We're going to run it again. I'm going to run it a bit longer this time, so we can actually see what happens. And we're going to see what happens if we run it a bit longer. So no questions, because otherwise, if I'm going to answer the question, I'm going to be talking longer than the attack is actually running. So it's transitioned into running. So I'm going to try again, and now I'm going to buy myself a Gremlin swag pack. Add it to the cart, try and check out. It still works. All of those functions are still available. Sydney, yep. A lot of shipping costs from the Netherlands. Pay now. And I'm not getting any order response whatsoever at this point in time. So there's a couple of things we can learn from this. Is first of all, if this happens, we see that we are not getting a proper error message. So we're not going to share with the end user what is going wrong. They're just getting an empty page. I can guarantee you they will start clicking around in your application, not finding the reason if their actual order was placed, yes or no, and then we'll probably start wandering off to another environment. So in this case, we need to make sure that our monitoring picks up on situations like these. So we need to make sure that if we're depending on external services, that our monitoring is capable of picking up on that. But next to that, if this fails, we need to provide the end user with a much better and understandable error result. So this is basically the outcome of this chaos engineering experiment. Monitoring needs to be improved, and our application needs to handle this failure in a much, much better way.
Okay.
Cool. So next step. So which of these can we do with a black hole attack? Well, we can block specific traffic to a port of a server in our data center, which is not under Gremlin's control. Yes, we can do that because we can target a external service and really fine-grain filter the traffic we're talking about. We can exclude IP host names, etc. from attack? Yes. Can you block random traffic to random pods in a Kubernetes cluster? Yes, you have the ability to do that as well. Block traffic from an application towards an AWS DB service. Well, I explained that as well. And can we simulate a complete data center failure? Yes, you can. So I briefly mentioned already that you can place tags on systems and components in your environment. If you deploy your systems on a cloud provider, those tags will be identified automatically for you. But if you run them in your own data centers, you'll realize that we don't have those APIs that the Gremlin agent can scrape. The agent also has the ability to attach manually attach tags you want to be using against your system. So you can say, for example, I've got these systems running in data center A, got these systems running in data center B, and apply specific tags to those. Then I could run a black hole attack selecting all of the systems or all of the components that have a tag called data center B. And in this case, simulating that the entire data center B is failing and is not responding at all to see how our application would handle that. So yes, that is absolutely a possibility of the platform itself.
Very powerful attack, can take down pretty much everything.
Yeah, so black holes and latency are probably the attacks you'll definitely see most. So those are the three main infrastructural attack types we have. Yeah, with state attacks, resource attacks, and networks attacks. Based on their own, pretty powerful already. But what happens if you want more complex situations? So in this case, we have the ability to create scenarios. And scenarios help you to glue multiple types of attacks together. Where do we use that for? Well, for example, if we are running we're trying to simulate a failure we had last month. Yeah, we had an issue where one of our database servers was seeing an increase in CPU consumption. And that CPU consumption slowed down the database. The web application in front of that database, the result for that application was that traffic towards that database was slowed down, seeing it as a bunch of latency. And at some point in time, the web server that was in front of the application server started to time out because of that. It's fairly difficult to create that based on individual experiments. However, if you can glue all of those experiments together in scenarios, you can start really introducing the CPU load, then start introducing network latency, and then at a certain point in time, even block complete requests from the end user towards the web server, and basically mimic the same failure scenario you had in your real life scenario. The advantage of that, you can actually see how your monitoring solution picks up on that. Does it identify the challenge going on, the problem going on already in the phase where the CPU load on the database is increasing? Or is it only seeing whenever the timeouts on the web server occurs? We want to do that as early as possible in those stages. We want to make sure that we identify those issues before they become an actual outage. So we want to look for the signs in our monitoring that tell us about that. So in this case, what I want to do here is I want to create a horizontal pod autoscaler, just like I just mentioned. So I'm going to set Kubernetes up so that it's going to scale out the web deployment whenever CPU load gets a bit higher than I anticipated on. So let me get the namespace again. Mary Bean, yes. So this is going to set a auto scaling policy on the web deployment from my application, and it's going to tell it that whenever that goes above 50% CPU capacity, we're going to increase the amount of deployments we have up to a maximum amount of 10 deployments. So let's see if we, sorry, not pods. Get HPA. So let's see if the autoscaler has been configured. Yeah. So we see indeed the autoscaler has been configured for that web deployment, and it's now currently at 1% CPU load. Well, the target is 50%. So once the pod goes over 50%, we're going to scale up the deployment. Important to know here is the way that Kubernetes uses meters the CPU is different in the way that Gremlin does. So Kubernetes uses the amount of CPU that is reserved by the deployment itself. So you're going to set CPU reservations in the deployment YAML file. And those are going to be based on the amount of CPU cycles in the system itself. Well, if we're going to run an attack in Gremlin, we're going to do that based on the host CPU. So we got a bit of calculation rule that you have to make on how many cycles in Gremlin would that relate to in Kubernetes. In our case, it's a relatively simple factor, just divided by 10 to have the proper effect. So I'm going to create a scenario in Gremlin now that has basically 4 steps. We're going to increase it at 1%, then to 3%, 6%, and 10%. And we're going to run those attacks for a minute to see what happens if we slowly, gradually up the CPU usage. So I see there's a couple of guys that are actually running those scenarios already. Cool. CPU HPA test is what I'm going to name it. My hypothesis is HPA works as designed. Of course, I normally would have a much more sophisticated hypothesis in there, but for this case, I'll leave it fairly simple. I'm going to add a new attack. I'm going to add a Kubernetes attack, and I'm going to run that against my cluster in the proper deployment. And I'm going to select the web deployment, choose a Gremlin, a resource attack, CPU-based, whatever, for 60 seconds. And I'm going to use 1% across all cores. And let's see, all containers just to be served. Okay, cool. So that's the first step in my attack. Now I can add an additional one. I'm going to add the same attack. It's already populated that for me, luckily, so I can just now say, you know what, 3% please, and add another run. And then we're going to increase it to 6%. And finally, we're going to run it against 10% to see what happens. So I'm now just tying 4 different types of CPU attacks together, saving the scenario, and we're going to run the scenario. So once that is starting, is now trying to determine which agent to set up with it, scheduling that in the queue for the agent to pick it up. And just in a second, it should be running. Yeah, so the first one is now actually running in our environment. So let's see if we can already see the effects of that. So it's going to probably take a bit of time before it picks up on it, although 1% is going to roughly look at 10% in actual usage on the system. That's my expectation, at least. And indeed, we also really see it go up. It's actually above that 10%, but it's still underneath that 10%, 3% of the next attack. So once that's run, and that's going to run about a minute or so, it's going to increase that to 3%. So that's going to go up to at least 30% and higher. And the next one would go over to 6%. And that's where I anticipate my HPA to kick in and start scaling up the actual deployment. So it's going to be fairly stable on this one right now. So let's give that a go. So let's see what my application usage looks like. Can we see this already in CPU usage? Kubernetes, that's what I'm looking for. Nothing specifically over here yet. It'll take a while. Cool. Are we still running this one? Yep. Okay, so now it's finished the first attack. It's going to the second one. So there's a delay in here right now. One of the things that I could have done in my environment as well is to provide status checks. So if my application is accessible through HTTP or HTTPS, I can have Gremlin poll the application to see if it still works, if it still provides a error 200, or does it provide an errorless HTTP code? And if it responds, what is the latency in there? And I can set thresholds. So, for example, if during those attacks the latency goes above a certain threshold, I can tell Gremlin, you know what? Stop the attack, revert the effects, because we've just hit a latency limit that we defined as being our failure factors. So in this case, it's now going to be running the second attack. So let's see what's going on over there, and immediately see that it's now going above the 50%. I was anticipating it on a later stage, but okay. And you can see that immediately the HPA responded by scaling up the amount of replicas from 1 to 2. In the next step, if it's going to be across the next phase in the deployment, it's probably going to end up to scaling up to 3 or 4 replicas during that attack. So maybe it's time to actually show you as well what happens with that big red button I also mentioned. So we've got the hold scenario and the hold all attacks going on. What if everything is going wrong, and all of my attacks going on are resulting in complete disastrous results, and my application goes down? I just hit that button. I confirm that I want to stop all of the attacks going on. Sorry for the person that was running a scenario on the other cluster. That's going to be halted right now as well. And we immediately see that it was halted by the end user, and it's now reverting back all of the attacks. So if I look at this specific attack, look at the logs, you'll see that it was interrupted, it's rolling back the attack and cleaning up the Gremlin as it did. This is because I clicked on halted. There's also a couple of safety measures in the agent itself. So, for example, if the agent is incapable of communicating with the Gremlin platform, it's going to also stop these attacks. Yeah, remember, it's all about safe, controlled experiments. We don't want an experiment to go rogue, taking down the entire application platform. Every experiment you do has to be done in a safe and controlled way. So there's a couple of measures in there to help you execute those safely. So let's see what the final exercise looks like. Oh, there was was already one. I ran through them. I was expecting one more, but we went through all of the environments.
That's a great walkthrough. So it turned out even better that for the participants that now I have the personal walkthrough with Patrick through all the tasks, and great explanation. That's a great resource for you, everyone. Mm-hmm. And whenever the system is running, you will be able to spin up your cluster as well and do it on your own.
In the meantime, I did receive a response from the Instruct guys, and it turns out that because of some abuse they had over a few times ago with crypto miners, they added some quota controls on the GCP projects which we're running into right now. So that's slowing it down and ultimately limiting them. So if you're not able to run these clusters, check back tomorrow, or you know what? I'll extend the amount of time for a couple of days as well, so you can play the entire track and do that on your own pace as well.
That's great news. Thank you so much, Patrick.
Yep.
But it's also a pity that we cannot mine bitcoins anymore with this.
Well, the interesting thing is Instruct is also used for product demos on public websites. So what you'll probably see is that if somebody does a product demo on their own website without registration, that's why we use those registrations and those invites, and they haven't crafted their demo systems correctly, they can be excellent resource or capacities for doing things like crypto mining or running botnets and stuff like that. So yeah. I understand the reasoning for putting those quotas up, but I need to have a discussion with them on how we can work around those for the next set.
Absolutely. Yeah. Cool. Any system like live system like this is prone to abuse and misuse. So that's why they have to pay attention. We're also frequently using another one called Quick Labs, and it's a similar story with them. Whenever you do a step left or right, for deviating from your usual path of the class, that's it. That's a very quick way to look you up, and that's then you have to go to support and ask.
So in a normal situation, normally you would have run this bootcamp. You would have gone through all of the exercises yourself. And I would be telling you right now on what would be the next steps if you want to play around with the chaos engineering inside your own organization. And then first thing I want to emphasize is there's basically 3 phases in the adoption journey of chaos engineering. The first one is what I call experimental chaos. You're going to be running around exercising days like these. Organize your first game day, get your teams together, manually create those experiments, run them manually, and look at what the effects of those experiments is going to be, and start learning based on those. Once you've done that a few times and you've identified weaknesses in your application, it starts to start planning those. Ultimately, making those experiments automatable, so you can make them part of your continuous integration, continuous deployment pipelines. And the final stage where customers go through is when they're going to automate chaos. And automate chaos is based on not only testing in production. That should be your end goal, being able to test if you're still resilient enough in production. Basically, what Netflix is doing with their Chaos Monkey, they deployed the Chaos Monkey in their production environment, taking down virtual machines at random, making sure that their applications are still capable of handling that underlying infrastructure failure. Being alerted as quickly as soon as somebody makes a change to the application landscape, that reverts that back, and they run back into the failure mode they had in the past. The other part of automated chaos is actually scheduling and automating chaos as part of fire drills. As I mentioned, schedule an attack to run tomorrow morning at 9 o'clock in the morning, whenever your engineering teams have just come in. They're in their first sip of coffee, and start looking at what happens if their applications start causing issues. Sit down, relax, and have a look at that. And that's going to be part of not only of the processes, and you need to integrate that with your tooling, it's also become something that needs to be part of your culture. You need to create a culture of chaos inside your organization. And there's a couple of things where you can track your CE practice with how successful are you with implementing chaos engineering. The most important metrics that are going to identify your success are the following ones. There's KPIs, and the KPIs are your key performance indicators. And in the SRE space, these typically include things like SLOs, error rates, response times of critical services, and availability numbers. And the 2 most important ones that most organizations are looking at when they're starting to practice chaos engineering is your MTTR and your MTTD. So your mean time to detect is the average time it takes for you to discover that there's an incident at hand, and the mean time to recover. What is the average time it takes us to remediate the incident and get back to normal operations? And whenever you run an experiment, at the end of the experiment, you should be asking yourself the following 3 questions. First question, was it expected? No, that's perfectly fine because you've actually found a weakness before it came an outage. So was it detected? No, awesome, because there's a great opportunity to improve your monitoring and bring down that MTTD in the end. And the final one, was it mitigated? Because it's going to surely feel a lot more comfortable when you're working on resolving an issue, knowing that your users can still access your service. So it's not about was the experiment a failure, it's what have we learned from our experiment. And that can be either the experiment didn't show us anything, everything worked as expected, well, then it was still a successful experiment. If the experiment failed and the application went down, it's still a successful experiment because you've learned a valuable thing about how your application responds under stress. So there is no right or wrong when it comes to successful or unsuccessful chaos engineering experiments. It's all about, have we learned something? And if we haven't learned something, then everything was fine, perfect. Then the next time is going to be in acting. Yeah. If this experiment absolutely fine, nothing was introduced, can we automate this? Yeah, can we have this experiment be run from our CI/CD pipeline, that validating that any code change we make in the future doesn't result in a regression of that issue? If the application broke down, let's fix the issues. Let's make sure this doesn't happen when we're going into production. And finally, and I've mentioned that already, share your result. Yeah, measuring the cost of downtime is not always on everybody's mind. Let your management know which successes you've achieved so that they know that we saved ourselves from unnecessary downtime. So as I mentioned, this environment is going to be accessible for a few more days. I'm going to extend that for about a couple of days, so to give everybody a chance to run through the hands-on exercises. If you want to play around with it yourself, there's an excellent tutorial on the Gremlin website as well to build out a similar environment as we've been using today. On EKS, deploying the Gremlin agent, etc. So reach out to that website if you want to build this setup on your own platform as well. So with that being said, we've reached the end of what I had to explain. What we're going to do is everybody that has completed the hands-on exercises, and that's going to take us probably a few more days, we're going to send out the certificate of completion you see here on the screen, so that you can actually show that you've had your first hands-on experiences with chaos engineering and the first experiments and so on. So that's what we're going to do automatically. Again, make sure when you registered for Instruct in your profile, make sure that you use your full name that you want to have on the certificate of completion. Otherwise, we're going to have to send you an email, an empty one, or with only your email address, and that would be a pity.
That's great. Thank you, Patrick. Anything else to add? Sorry, I interrupted you just now.
No, that's good. I was about to hand over to you.
Okay, cool. So that's an amazing looking certificate. Make sure everyone to complete your bootcamp. Aside of this knowledge which you will gain, it's also a certificate of completion which we will receive. As a platform, the environment will be open for a couple of days, as Patrick said, but don't take chances with this. Just as soon as it will be available, maybe like, I don't know, like tomorrow in the morning probably is a great time to try it out. Just make sure to go push for it and complete the instructions. Patrick walked you through all the steps. It will be just a breeze walkthrough, for yourself. So take a chance and do this, complete this thing. Meanwhile, I posted the form, link to the form of where you can provide your feedback about this event. But you will also, by doing so, you will also be eligible for our raffle, which we will run just in 1 minute or so. So take a break, fill out the form. We have 84 submissions as of now, way less than people in the stream. We have about 100 people right now in the stream. So yeah, why not to take chance and participate at the raffle as well? Any other final words, Patrick, from your side? What your company is actually doing, Nuaware? It's a consulting company, right?
Now we're a software distributor, so we focus mainly on cloud-native technology. So we work with a lot of vendors in this space, and what we typically try to do is work with vendors that are startups, come across to Europe and try to build out the European market. So we try to be on the bleeding edge of technologies, and yeah, Gremlin is one of those companies we've onboarded in a really early stage, trying to get into the European market. And the way we do that is we help them set up their sales processes, but also run these kind of workshops to get the technology awareness in the market, etc., etc. As I said, we do that for a lot of vendors in the cloud native space. So we work, for example, really closely with a couple of Kubernetes vendors. We work with Portworx for Kubernetes storage. We work with security companies like Prisma Cloud from Palo Alto Networks, which focus on cloud of container security and cloud security posture management. We look at application lifecycle security with companies like Sonatype, and there's a bunch of other small startup vendors that we try and work with to get traction into Europe. So we're a software distributor, but not the typical software distributor your organization are typically used to work with.
That's a plenty of things that you guys do and offer to your customer. That's great. I also checked out your homepage, and that's a very interesting thing. Whatever you do, people, whenever you finish this bootcamp, you will receive also the certificate. And you can also post it on social media, on Twitter, LinkedIn, whatever you are using. Make sure to tag, you can tag Patrick, you can tag our community as well. Also the company where Patrick is employed, it's Nuaware. And also Gremlin, you are using actually Gremlin. You will be using Gremlin for this bootcamp, and I'm pretty sure people at Gremlin will be happy to see them tagged as well. That's just a recommendation from my side. And now we have 65 submissions for the raffle, and I'm going to share my screen now. Let's see if it will be visible. It should be coming through right now. Yeah. So you see this, the wheel of names, it's called. And we will shuffle it a few times. As I said, we will have 5 winners today. And because we have 5 t-shirts to share with you guys, let's run for the first spin. I'm not sure that you can hear the sound of the spinning wheel, but if so, that's great. The first winner is Shashank Mishra. Thank you, Shashank. And let's shuffle a few times more so that we have a close to random selection here. And the second spin goes. Yeah, it's very close, but Salam Kovchu for his advantage. Congratulations. Let's shuffle again. And the third spin now. And the third winner is, congratulations. Shuffle again. And the fourth spin. It's again a close one, but Srinivasa won it. Congratulations, Srinivasa. Winner. Shuffle it again a few times. And the last spin for today. Who is it? It's Hartanto. Congratulations, Hartanto. Winner. Everyone, all the winners, I will get in touch with you, and we will figure out your postal address, and t-shirt size probably we will also require from you. And you will be shipped the original Gremlin t-shirt. That's it for today. Thank you, everyone. It was a great pleasure to be with Patrick today, to be in this bootcamp with everyone. And hopefully you will enjoy the follow-up completion of the bootcamp. If you will have any questions whatsoever, you can always hop into our Slack, Discord, or Telegram, and the links, invites to all these spaces you will find in the description of the event. It's always there. So thank you, Patrick, again. It was a great pleasure to be with you here today. And yeah, it would be great to host you again at some time.
Thanks for hosting, Karen. Pleasure to be here.
Great. Okay, everyone. So yeah, let's go on your own and complete the bootcamp, and let's connect in our spaces later. See you.